Welcome back, Algebra 2 people. We are going to move into section 5.4, which is on page 12 in your packets. And we're going to talk about finding x-intercepts of polynomial functions and then using them to do some graphing. Hopefully you remember from the last unit with our parabolas. Our x-intercepts, well, I've got 3 x-intercepts for this particular polynomial function. They're all in the form some number comma 0. So, how do we find x-intercepts if we're not using the calculator? You may or may not have already seen how to do these in the graphing calculator. If not, we'll look at that in class soon. But to find these things by hand, all we need to do is plug in 0 for y and solve. All we're going to do to find our x-intercepts is plug in 0 for y and solve. So we have 3 different polynomial functions we're going to go and try to find x-intercepts of. I'm going to plug in 0 for y over here, and I'm going to get 2x minus 6. Oh, this is a really easy equation. You know what? You go solve that equation, and when we're done, just tell me x equals. I don't even need coordinates at this point. Let's just tell me x equals for the answer. Find the x-intercept in letter A. Plus 6 plus 6. 6 equals 2x. Divide. X equals 3. You should have one x-intercept at x equals 3. In letter B, we're going to plug in 0 for y, and we're going to get x squared plus 5x plus 6. Oh my goodness, what do you know? It's a quadratic equation. I think it's a factorable quadratic equation, so if it was me, I would factor that thing, then set the 2 parts equal to 0. Please go do this and tell me what the 2 x-intercepts are. Multiply to 6, add to 5, I think that's x plus 2, x plus 3. So I'm getting 2 x-intercepts, x equals negative 2, x equals negative 3. And then if I was graphing this, I could plot them and all that good stuff. Letter C, I want to find the x-intercepts. Well, I'm going to plug in 0 for y. 0 equals x cubed plus 6x squared plus 11x plus 6. All we have to do here is factor this thing, and then I can set the parts equal to 0. But there's a problem. I don't know about you, but I don't know how to factor something like this. We're going to say in general our direction is factor. Problem here is, but we don't know how. And we're not going to talk about factoring something like that today. We'll get into that as we move through the units. But for today, what we're going to deal with is polynomial functions that are already factored for us. And if they're already factored, we can find the x-intercepts pretty easily. This whole section is going to be about dealing with polynomial functions in factored form. And this kind of corresponds to what we did with our parabolas. We've spent today with parabolas in vertex form and our transformations. That was kind of like section 5.2, where we took our x cubed and transformed it. Then we looked at parabolas in standard form. Well, that was kind of like what we did in the last section, things that were already foiled out. We could figure out our end behavior and a few pieces of information, but not absolutely everything, and the y-intercept. Now, we're going to deal with polynomial functions in factored form, kind of like our parabolas in factored form, where it will be very easy to find our x-intercepts, our zeros, our roots. So, let's take a look at letter A, factored form polynomial functions. We have this polynomial function over here, and I want to find the roots. And remember, roots are a fancy name for x-intercepts, also sometimes called zeros. They all mean the same thing. I want to find those. I'm going to go and I'm going to plug in 0 for y, and I'm going to get 0 equals x plus 1, x minus 2, x plus 3. All that we have to do is set our 3 factors equal to 0. No, I don't have to see this work. X plus 1 equals 0, x minus 2 equals 0, x plus 3 equals 0. I'm going to solve those little equations. Again, no, this is the one time I don't need to see that work. and I'm going to get 3 x-intercepts. I'm going to get x equals -1, x equals 2, and x equals -3. See if you can do the same thing in letter B. Find the x-intercepts in letter B, please. Well, from over here, x plus 7 equals 0. You go solve that, you're going to get x equals -7. From over here, x minus 5 equals 0. You're going to go solve that. I'm getting x equals 5. However, there's another one. That 4x up front, I'm going to set that equal to 0. If it was just a 4, I'd have 4 equals 0, and that wouldn't give me anything. But because of the x, I can solve this dividing both parts by 4, and I'm getting x equals 0. There are 3 x-intercepts here. X equals 0, x equals 5, and x equals -7. Where did the 0 come from? From the x that was out front. With that in mind, see what you can do in letter C, and in C, I think it would be very helpful to write out the little equations and solve them because, well, it's a little bit more involved. See what you can do in letter C, and please give me fraction answers, not decimals. My 3 little equations are 3x equals 0, 2x minus 3 equals 0, and 5x plus 6 equals 0. I'm going to solve. Divide by 3, divide by 3, x equals 0. Over here, plus 3, 2x equals 3, divide, x equals 3 halves. Last one, minus 6 minus 6, 5x equals -6, divide, x equals -6 fifths. There are 3 answers. X equals 0, x equals 3 halves, x equals -6 fifths. Take a moment to get any notes down that you need to. Next thing we're going to take a look at on the next page, page 14, something called multiplicity of roots. Multiplicity is defined as the number of times a root, a 0, an x-intercept shows up. Multiplicity is the number of times a root shows up. And I'm not expecting that to make perfect sense right now. I'll show you exactly what this means in just a moment. Multiplicity is the number of times a root shows up. For example, in letter A, I want to find the roots and their multiplicities of this polynomial function. Y equals x minus 1 squared times x plus 2. Well, first of all, x minus 1 squared is the same as saying x minus 1 times x minus 1 times x plus 2. I'm going to set each of those factors equal to 0. I'm going to get x equals 1. I'm going to get x equals 1. And I'm going to get x equals -2. And what you should notice is x equals 1 showed up twice. Rather than writing it twice, though, the better way we can write this is we can say x equals 1 with a multiplicity of 2 and -2. Those are my roots with their multiplicities. And if you don't say a multiplicity, it's implied that the multiplicity is 1. So it's basically like the multiplicity of -2 is 1. There's an easier way to find the multiplicities. I think the multiplicity is really just going to be the power on the factor that gives a particular root. Let me add that into my definition. I can also think about this as the power on the factor that gives a root. X minus 1 had a power of 2, so x equals 1 has a multiplicity of 2. Let's try the next one. Letter B. I have 3 pieces over here. From the x cubed, I'm going to get x equals 0 as one of my roots. The cube means it's going to have a multiplicity of 3, because this is really like x times x times x. There's 3 of them. How about you find the other x-intercepts and tell me their multiplicities? From x minus 5 to the 4th, we're going to get 5 with a multiplicity of 4. And from x plus 7 squared, I'm going to get negative 7 with a multiplicity of 2. See if you can do letter C. Tell me the roots and their multiplicities. Okay, well, the x squared, I don't care about the negative 3. The negative 3 won't affect anything, but the x squared itself will give me 0 with a multiplicity of 2. X plus 1 cubed is going to give me negative 1 with a multiplicity of 3. X minus 9 is going to give me 9 with a multiplicity of 1. By the way, why do we care about multiplicities? We're going to see at the end of this video, the multiplicities will affect the shape of our graph. More coming later. Hold on to that for right now. Next thing we need to be able to do is we need to be able to, well, convert from factored form to standard form. This is really not a big deal. I've got this polynomial function in factored form. I think you already know how to convert it. All you have to do is FOIL, distribute, all that good stuff. If it was me, I would go and FOIL these two pieces. And when done, I would distribute the x to that. See what you can do. And when you're done, send your answer into Edpuzzle. By the way, how do we do this? A whole lot of foiling, a whole lot of multiplying. What's the answer to letter A? Okay, so I'm going to multiply those. I'm going to get x squared plus 3x minus 2x minus 6, and I'm going to combine like terms before I finish. So x times x squared plus x minus 6. I'm going to distribute the x, and that gives me x cubed plus x squared minus 6x. Same function. This is my standard form. This is my factored form. In letter B, I think you remember how we deal with the square. What am I going to have to do to deal with that square? I hope you just said, write it out twice. This is going to be y equals 2 times x plus 2 times x plus 2 times x minus 1. See if you can deal with this one. You'll send your answer into Edpuzzle when you're done. And please make sure your answer is a function, so make sure you've got that y equals on your answer. I'm going to multiply these two first, but you also could have done x plus 2 times x minus 1. Definitely going to combine like terms before I move on. So 2 times x squared plus 4x plus 4 times x minus 1. I'll save the 2 for the very end. I'm going to go and multiply these things now. And I'm going to get 2 times x cubed minus x squared when you do x squared times both of those. Then plus 4x squared minus 4x when you deal with that piece. Then plus 4x minus 4. I'm going to combine things here, and I've got 2 times x cubed plus 3x squared. Well, that's nice. Those canceled. Minus 4. Final answer is going to be y equals 2x cubed plus 6x squared minus 4. Oops. I'm going to make the video pause so you can get caught up on anything you need to. Next page, page 14. Now what I want to try to do is create some polynomial functions from their roots. For example, I want to write in factored form the polynomial function with roots 4, 9, negative 2, negative 5. Here's how I'm going to do this. I want a function, so it's going to be y equals. I want a little factor that when I set it equal to 0, I get 4 for an answer. that little factor is just going to be x minus 4. So I'm going to say in parentheses x minus 4. Next, I need a little factor that will give me 9 for a solution. What little factor would give me 9 for a solution? I hope you typed in x minus 9. Okay, next. What little factor would give me negative 2 for a solution? I hope you said x plus 2. And then, what little factor would give us negative 5 for a solution? Well, x plus 5. Let's see, I was told to do this in factored form, so actually it looks like I'm done. That is my factored form polynomial function with roots at 4, 9, negative 2, negative 5. Next, I would like to write this thing in factored form. Well, y equals. If I have 0 as a root, what must I put in my function? I need an x. Actually, it could be 2x, 3x, 4x, negative 5x. I don't really know. I'm just going to leave it as x, but really, if you put any other number in front of it, for right now, that will be okay. You know what? I bet you can do the rest of it. See if you can figure out 2 multiplicity 3 and negative 1 multiplicity 4. How am I going to get 2? I want x minus 2. I want a multiplicity of 3, so I'm going to say cubed. Then I want negative 1 with a multiplicity of 4, so I'm going to say x plus 1 in parentheses to the 4th. And that's my final answer. Next one, write in factored form the polynomial function with those roots, then convert to standard form. Take a moment to do the factored form, stop, and then we'll deal with standard form. Okay, if I want 0, I'm going to do an x up front. If I want 1, I'm going to do x minus 1, but I want the multiplicity to be 2, so I'll put a square over there. And then I want a negative 1, so I'm going to say x plus 1 at the end. You go convert to standard form and send your answer into Edpuzzle. You're going to have to write this thing out twice. A lot of foiling, distributing, all that good stuff. So that's my factored form. Y equals x minus 1, x minus 1, x plus 1. I'm going to start with these. Doesn't matter. Your work will look a little different if you start with x minus 1, but you'll get the same final answer. I'm going to say x times x minus 1 times x squared minus x plus x minus 1. This becomes y equals x times x minus 1 times x squared minus 1. I'm then going to multiply those two pieces. Y equals x times x cubed minus x squared minus x plus 1. And I'm going to finish by distributing the x. Y equals x to the 4th minus x cubed minus x squared plus x. And that is my final answer in standard form. Answer in factored form, answer in standard form. There's one last thing we need to take a look at, and in my opinion, this is the trickiest part of what we're dealing with today. Graphing factored form polynomial functions. So we're going to finish up the notes, and then, in a separate video, you're going to do a little bit of practice with this stuff. I want to graph the polynomial function f of x equals x minus 1, x plus 2, x minus 4. Step number 1. The first thing I'm going to do is I'm going to find the roots, zeros, x-intercepts, plot them, and note their multiplicities. Step number 1, I'm going to plot the roots and note the multiplicities. Plot the roots and note the multiplicities. Okay, Well, let's see here. X equals 1 is going to give me, x minus 1 is going to give me x equals 1. I'll plot that. X plus 2 is going to give me x equals negative 2, and x equals 4 is going to give me x equals 4. I'm not going to bother doing anything with the multiplicities. We'll save that for a problem where we actually have multiplicities. I need to know if when I graph this, I should start up here or if I should start down here. I need to figure out my end behavior, which means I need my leading term, which means I need this thing in standard form, and that's going to be a pain, especially once I start adding in multiplicities and all that. So there's a little trick that I can use to figure out, actually, I don't need this entire thing in standard form. I only care about the leading term, and there's a shortcut I can use to get that. Number 2, I'm going to determine the leading term of the polynomial function. Determine the leading term of the polynomial function. We're going to do that by just multiplying together the leading term of each factor. By multiplying the leading term of each factor. The whole point of that was so we could find the end behavior. So I'm then going to say, use this to find the end behavior. Use this to find the end behavior. I'm going to give you a moment to finish copying that, then I'll show you what I mean. To find my leading term, I need to take the leading term of x minus 1, that's just x, times the leading term of x plus 2, that's also just x, times the leading term of x minus 4, that's also x. My leading term is x cubed. This looks like an odd degree with a positive leading coefficient. According to what we did in the previous section, in section 5.3, what is our end behavior? I hope you chose down and up. Odd, I know they're going in different directions. Positive, I'm going to end by going up. Because of this, I know I need to start my function down here, because I need to start by pointing down. All I'm going to do is make my function pass through those x-intercepts. Now, sometimes it's a little bit more involved than that. Not here. I'm going to start over there, and I'm going to go through my first x-intercept. To be able to go through the next one, I've got to make this thing curve around. Now, how high exactly should we go? I don't really know, and I don't really care. That's why I didn't put tick marks on the y-axis. To figure out more specifics of this, we need to use the graphing calculator, or we need to use some tools that you will see in pre-calculus and calculus. For now, I'm just going for the basic shape. I need to curve around, and then I'm going to go through that x-intercept. How am I going to get through the next one? I'm going to curve around, and I'm going to go through that one, and it's going to end like that. To put this into words, I'm going to start at the left end behavior. Start at the left end behavior. Then I'm going to approach each root. If my multiplicity is 1, I just go straight through them. If the multiplicity is a different number, which we'll see in a moment, we're going to do some different things. So I'm going to say, approach each root and use the multiplicity to determine what to do there. Use the multiplicity to determine what to do there. start at the left end behavior. So my left arrow was pointing down, I started down. Because my multiplicities were 1, that's going to mean just go straight through the x-intercept, so I'm going to go straight through there. To go straight through here, I've got to curve around. To go straight through there, I've got to curve around again. And I'm going to get something that looks like that. I'm going to make this pause so you can finish copying, and then we'll do some more examples. Okay, so on the next page, we're going to take a look at this polynomial function. How about you take a moment, find and plot the roots. The -4 up front does not have an x with it. So you set -4 equal to 0, and you don't get anything. We're not going to get any roots from there. We're going to see the -4 will be important for something else, though, in a moment. From x minus 3, I'm going to get x equals 3. From x plus 1, I'm going to get x equals -1. From x plus 3, I'm going to get x equals -3. And from x minus 1, I'm going to get x equals 1. Those are my 4 x-intercepts. Next, I need to find my leading term. I'm going to multiply the leading term of each piece, including that leading term of a -4 that's out front before the entire problem. I'm going to get -4 times. Leading term here, just x. Leading term here, just x. I'll give you a hint. It's basically always going to be x. Well, maybe with a power, but basically always x. I've got another x there, I've got another x there. This gives me -4 x to the 4th. Using what we did in the previous section, what will the end behavior be? Even, so they're going in the same direction. Negative number out front, so down and down. Here we go. I'm going to start down here. You know what? How about you take a moment, see if you can do this one. Going to go through that first x-intercept. Got to curve around so I can go through the next x-intercept. Got to curve around so I can go through the next one. Got to curve around so I can go through the next one. And my polynomial function looks something like that. Now, there's one last piece we need to add in here. If we have roots with multiplicities other than 1, first of all, if our multiplicity is 1, we're going to go straight through the root, like we've been doing. It's going to look like that, straight through. Kind of like a little line. If the degree is 1, multiplicity is 1, kind of like a little line. We just go straight through. If the multiplicity is 2, we're going to hit the x-intercept and bounce off it. Kind of like a little parabola. Parabolas have degree 2. This has a multiplicity of 2. I'm going to bounce off like a parabola. Finally, if my multiplicity is 3, multiplicity of 1 was kind of like a degree 1 function, like a line, like a linear function going straight through. Multiplicity is 2. Multiplicity of 2 is kind of like a function with a degree of 2. Bounce off like a parabola. Multiplicity is 3. Well, you know if we have y equals x cubed, it's that cubic function. And I'm going to do like a little cubic shape over here. I'm going to describe this as flatten and go through, like a cubic function. Flatten and go through, like a cubic function. Please make sure you copy those shapes down, and then I'll show you some examples. We're going to do 2 in the notes, and then in a different video, you're going to do a little bit of practice, and I'll show you my work and all that good stuff. Letter A, I want to graph this polynomial function. I'm going to find my roots and I'm going to note their multiplicities. The x out front gives me x equals 0. And I'm going to put a little 1 by it because my multiplicity is 1. X minus 2 gives me x equals 2. And I'm going to put a little 2 by it so I remember I need to do my multiplicity of 2 shape. I need my leading term. My leading term here is going to be x times not just x, but over here I'm going to say x squared, which gives me a final leading term of x cubed. What will our end behavior be? I hope you said down and up. I'm going to start down here. My first x-intercept has a multiplicity of 1, so according to my rules, I'm going to go straight through the root like we've been doing everywhere else. Go straight through, wonderful, and then I'll curve around. My next x-intercept has a multiplicity of 2. I need to hit it and bounce off it like a parabola. So I'm going to do something like this. By the way, my end behavior said I should end by going up. Yeah, I did that over there. I'm ending by going up. Let's do one more together. Letter B. You find the x-intercepts and their roots. And maybe see if you can get the leading term in end behavior as well. The negative 3 out front doesn't give me anything. If it was negative 3x, it would give me 0, but negative 3 by itself, nothing. X plus 3 gives me x equals negative 3. And that has a multiplicity of 3, so I'll stick a little 3 by it. X minus 4 gives me x equals 4. Has a multiplicity of 2, so I'll stick a 2 by it. X plus 6 is going to give me x equals negative 6. And I'll stick a 1 by it. I asked you to try to find the leading term. That's going to be negative 3 times. From here, I'm going to get an x cubed. From the next part, I'm going to get an x squared. From the last part, I'm going to get an x. If you multiply these together, you get negative 3x to the 6th, which tells me down to the left, down to the right. Here we go. I'm going to graph this thing. According to my end behavior, I'm going to start down here. I'm going to go straight through that first x-intercept and curve around. I've got 3 choices. What should I do at x equals negative 3? Should I go straight through it like a line? Should I bounce off it like a parabola? Or should I flatten and go through like a cubic function? I hope because the multiplicity is 3, you said flatten and go through like a cubic function. So I'm going to do something kind of like that. And this is probably the trickiest shape to get, and I really need the flattening to happen right on the x-axis. Then, what are we going to do at x equals 4? Go straight through like a line, bounce off it like a parabola, or flatten and go through like a cubic function? Because the multiplicity is 2, I need to bounce off it like a parabola, so it's going to look something like that. We're going to do a little bit more practice with these graphs in another video, but I want to stop here for now. This is all that we need in our notes for section 5.4.